coming to the last part of sulfuric acid, we will see that sulfuric acid acts as a dehydrating agent. Dehydrating agent means it helps in the removal of water. So, how sulfuric acid acts as a dehydrating agent? When sulfuric acid reacts with, that is hydrated copper sulfate. Now, hydrated copper sulfate is blue in color. If you add few drops of sulfuric acid into it, you will see it becomes white, anhydrous it becomes. Alright, that is CuSO4 dot 5H2O in presence of H2SO4 conc, concentrated sulfuric acid, will give you CuSO4 plus 5H2O. Water is removed. So this is blue color and this is white color. This is hydrated, this is anhydrous. Who helps to make anhydrous? Sulfuric acid concentrated. Similarly, if you take oxalic acid, this is oxalic acid. If you if you add few drops of concentrated sulfuric acid to oxalic acid, what you will find? Water will be removed. First you remove water, the best thing is that. Water you remove. So water you have removed. Then what is remaining? Carbon monoxide, and this is your carbon dioxide. CO plus CO2. So easy you can see that to write the reaction. Oxalic acid in presence of conc sulfuric acid. It acts as a dehydrating agent. So first I removed water. Done. Then what is remaining? CO and CO2. CO and CO2. Finished. Now if I take formic acid, HCOOH, in presence of same thing, concentrated sulfuric acid. First you remove water. How? See here. See, H2O. Then what it remains? CO. See here. CO plus CO. That is H2O. Alright. Similarly, if I take here, that is nothing but glucose, C6H12O6. Alright. And same thing, concentrated sulfuric acid, you add it. What you will get? Carbon and nothing but water. How many water here? H12O6. So 6H2O. Because see, 6 oxygen is there, so 6H2O in this way. Now you can also do this particular reaction with sugar also. You can do this particular reaction. Sugar is C12H22O11. Same thing, you will be getting 12C plus 11H2O. Now you can carry out this reaction, you can see. As I said in this case, it becomes blue to white. In this case also what you do is that you take a test tube, put some sugar, or put some glucose into it, and you add few drops, just 2 to 3 drops of concentrated sulfuric acid. Immediately you will see that the test tube is being filled up with a black foam. A spongy mass is being formed, a black color spongy mass. Immediately you will see that. Alright, so hence you should do this experiment away from you. Hence here you can keep it and do it in this way. Clear? So you will see the test tube is completely filled with spongy mass. After some time the spongy mass is going to settle down because water is being released, and you will see the black specks of carbon remains behind. Black specks. Specks means dots of carbon is remaining behind. So in all these reactions you can do the same thing with cellulose also. You can take cellulose, C6H10O5 and you can carry out this experiment. In all this experiment you can see that sulfuric acid acts as a dehydrating agent. Alright, it helps in the removal of water. Clear? Now, next is, children, I'll ask you one question to you, that what is the difference between dehydrating agent and drying agent? Dehydrating agent and drying agent. Now, the difference is, listen carefully, because many of them they do not know it. Drying agent is a physical change. Dehydrating agent is a chemical change. Drying agent removes physically the water from the surface. Suppose this is wet. This is wet. Now, if I use what you can say calcium oxide like quicklime or phosphorus pentoxide, if I use it, got it? Anhydrous calcium chloride, they are the drying agent. They are going to remove physically the water from it. That is called as a drying agent. Dry, it makes the substance dry. It is wet, it makes it dry. But dehydrating agent, what I said you, it helps in the removal of water chemically. Chemically, it's a chemical change. As you can see, so many examples I gave it just now to you. It's a chemical change. So, in case of drying agent, the chemical composition of the substance remains the same. But in case of dehydrating agent, the chemical composition of the substance changes. You can see it. When the chemical change is taking, the chemical composition of the substance is changing. Suppose if you are taking sugar, it gives you carbon plus water. The chemical composition changes. If you are taking oxalic acid, you are getting carbon monoxide plus carbon dioxide plus water. In this way, the chemical composition changes. Understood the difference? In case of drying agent, it's a physical change. In case of dehydrating agent, chemical change. Drying agent helps in the removal of water physically. and hence it does not change the chemical composition of the substance. But dehydrating agent helps in the removal of water chemically, and hence it acts as and hence it changes the chemical composition of a particular substance. Got it now? There is a difference between drying agent and dehydrating agent. Now, concentrated sulfuric acid acts as a drying agent for many other gases. Like it helps in the drying of oxygen gas, chlorine gas, HCl gas, then SO2 gas. Got it? It helps in also nitrogen gas. In all these cases, in all these gases, I can use concentrated sulfuric acids as a drying agent. I can use, but in H2S, got it, and ammonia, I can't use concentrated sulfuric acid as a drying agent. I can't use. In this case, I can use. Why? Because ammonia is basic, sulfuric acid is acidic, is going to react, and H2S, when reacts with sulfuric acid, you have seen it. It reacts to give you sulfur and water. Got it? You have seen it already. So in this way, what you find is that in these two cases it reacts. For that purpose, it is not used as a drying agent. But here it can be used in all these gases. It can be used as a drying agent. Got it? Now, next is if you see the test for what you can say sulfuric acid. What is the test for sulfuric acid? How will you come to know? Now, one of the tests is if you take barium chloride solution. Barium chloride. You take barium chloride solution in a test tube and add few drops of sulfuric acid into it. Few drops of sulfuric acid. You will get a white PPT of barium sulfate, which is insoluble in all acids. You will get a white PPT of barium sulfate. This is a reaction. BaCl2 plus H2SO4 will give you BaSO4. It's a white PPT plus nothing but 2HCl. Similarly, you can also take lead nitrate PbNO3 whole twice plus H2SO4. You will be getting PbSO4, again a white PPT, and HNO3. What is that? I am doing it here, you know. That is a double decomposition reaction. You see, plus minus, plus minus. See, Ba goes with sulfate and hydrogen goes with chlorine. Here also same thing, plus minus, plus minus. I am not writing the valency, mind it. I am writing the charges just to show you the double decomposition. Here lead goes with sulfate, see here, and hydrogen goes with nitrate. So 2HNO3, I can write it down here. That's it. So here also this is a white PPT. These two are the test of sulfuric acid. We can say that. Similarly, we can also use the reactions like copper when it reacts with sulfuric acid. Last class I have said you this reaction. It gives you nothing but copper sulfate plus water plus sulfur dioxide. Now sulfur dioxide gas is evolved. Now this particular gas, you pass it through acidified potassium dichromate solution. It will turn green. Acidified potassium dichromate is orange color. Alright, when you pass sulfur dioxide gas, it turns green. We can say that. Clear? So this reaction also we can say that. Now you have done the reaction with rock salt. Preparation from rock salt. What preparation? HCl preparation. So NaCl is rock salt. NaCl plus H2SO4 count below 200 degrees centigrade will give you what? NaHSO4 plus HCl. Now how is the test for sulfuric acid? Because HCl when is passed through a glass rod containing ammonia, it gives you dense white fumes, that is ammonium chloride. Alright, so hence you can see that these are the tests for sulfuric acid. Basically this particular test we use it regularly. This one or this one we use it regularly for sulfuric acid. Clear? Now another basic question we can say that how to distinguish between HCl, HNO3 and H2SO4. How to distinguish? Because already we have studied. Now this particular reaction, the first reaction is BaCl2, we can distinguish. BaCl2 when it reacts with H2SO4 it gives a white PPT or barium sulfate. Alright, but HCl will not give, HNO3 will not give, because barium chloride will react with nitric acid to give you soluble barium nitrate, or you can do with lead nitrate also. Alright, you can see it. So in this way you can distinguish it. Understood? HCl, H2SO4, HNO3. How to distinguish? First you take what you can say barium chloride, you add it to 3 test tubes. You will see in one of the test tube you will get white PPT. That particular test tube is sulfuric acid. Done. Now HCl, HNO3, how to distinguish? Very simple. HCl, you take a glass rod dipped in ammonia, bring it near the mouth of what you can say the test tube containing HCl, or you just add a few drops of ammonia in rest of the remaining of the 2 test tubes. You will see in one of the test tube it gives you a dense white fumes and you will be getting a PPT. You will be getting it. What is that? That is nothing but that is HCl. Or you forget about it. If you don't have that also, then what you can do is that you take silver nitrate. take silver nitrate, you add it to the two of the test tubes, because H2SO4 is understood. H2SO4 is gone. Out of 3, 1 we have understood. 2 we have to find it out, which is HCl and which is HNO3. You add, that is silver nitrate. You add silver nitrate solution to one of the test tube, you will get a white PPT, that is AgCl. So which test tube gives a white PPT? That is HCl. So other one is nitric acid. In this way you can distinguish between H2SO4, HCl and HNO3. Now coming to the test of sulfuric acid. Sulfuric acid is used for the pickling of metals. For example, suppose the metals which are coated with carbonates or sulfates or oxides. Before galvanizing, we wash it with sulfuric acid to remove this insoluble precipitate, and then we go for galvanizing. It is used in the preparation of use of HCl. It is used for the preparation of sulfur. It is used for the preparation of iodine. It is used for the preparation of carbon monoxide, carbon dioxide. It is used for the preparation of fertilizers like ammonium phosphate. We can say that it is used for the preparation of explosives like TNT, trinitrotoluene, trinitroglycerine. All these things we have studied in the chapter. Got it? In this way, sulfuric acid can be used for all these purposes. Got it? So we have discussed dehydrating agent. We have discussed the test of sulfuric acid, and also we have discussed the uses of sulfuric acid. Thank you very much.